Hey there, y'all. Alrighty, so today we're going to be going over just something a little bit different and kind of in a different style. Today we're going to be looking at radical expressions and how we simplify those. So, for radical expressions, it's anything that's underneath a radical sign, which is going to be essentially this signage right here. So anything that's in a square root sign, anything that's in like a third root sign. And so if it's underneath a square root, if it's underneath a cube root, anything like that, then we know it to be a radical. So let's keep moving. Let's work some examples real fast as far as simplifying. So simplify. So to simplify 196, the square root of 196. Well, the first thing that we want to do is we want to see if we have any perfect squares underneath here. So first thing that we can do in order to simplify this guy is let's go ahead and just divide it by 4. And if we divide it by 4, since we know 4 is going to be a perfect square, that means if we were to take the square root of 4, we would get 2, and then this 2 can then come out from underneath the radical. So the way to think about this is if we can separate this into a number, so 4 times 49, and so 4 times 49, well, both of these are actually perfect squares, and so the square root that we have can actually be separated into the square root of 4 times the square root of 49, and well, that just simplifies down to 2 and to 7. So 2 times 7, well, that's just 14. And if you happen to know that the square root of 196 is 14, good job. If not, well, then we figured it out kind of a little bit of a different way, but still got the same answer that we needed. Alright, moving on to the next problem. We have the square root of 75. Okay, so we do have kind of the same idea here, and we're going to see if we can figure out a way to figure out a perfect square times a number. So what's going to be some of our perfect squares? Well, our perfect squares are going to be 4, 9, 16, 25, 25. Okay, let's see if we can use 25. So if we have split this term up into 25 times, let's do 3, well, that's going to equal the same thing as the square root of 25 times square root of 3. And then this simplifies down to 5 square root of 3. And so this idea of being able to separate our term underneath the radical sign, if we can separate this term here into a perfect square times another number, then this perfect square can actually be moved out of the radical itself, and then all we're left with is just times the square root of 3. So moving into our next problem here, we have negative 9, we have negative 9 times the square root of 72. Well, let's see if we can separate this guy again. So we have, what is our perfect square? So we have 4, so 2 times 2, 3 times 3 is 9, 16. Oh, 9, we can actually go right there. So if we separate 72 into 9 times, well, 9 times what equals 72? 9 times 8. And then we can even separate this even further into 4 times 2. Well, we have two perfect squares here. We have 9 and we have 4. So that means that our 9 and 4 can come out from underneath the radical. And when we bring those out from underneath the radical, it's going to be, and actually let's rewrite it real fast. So we have negative 9 times square root of 9 times square root of 2 times square root of 2. Times square root of 4. Well, this can all simplify down. This simplifies down right here, and this as well. 2, 3 times 2 times negative 9 times square root of 2. And then if we combine all these terms right here, we get 3 times 2 is 6 times negative 9 is negative 54 square root of 2. Alright, let's keep going. Let's see if we can, and we have 8 square root of 252. Okay, let's take a look at our perfect square. So we have 2, whoops, not 2, we have 4. 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36. 36 looks tempting, but let's go ahead and let's keep it simple. So if we separated this into 4, well, 4 goes into 25 6 times, and we're left with 24 minus, so 3. 63 can be divided into 9 times 7, and then I think that's it. So we have our 2 perfect squares that we're using. And let's go ahead and rewrite this. So we have 8 times square root of 4 times square root of 9 times square root of 7. Well, our 4 and a 9 will simplify down to 2 times 3. And then we have 8 out here tailing along with us, as well as square root of 7. Well, 2 times 3 is 6, times 8 is going to be 48, square root of 7. So, moving on to our next problem, we have the square root of x to the 14th power. So in this case, we need to rewrite our radical as an exponent, so that way it just becomes a little more maneuverable for us. So if we have x to the 14th to the 1/2 power, which is the equivalent of our expression here on the left, so this right here is equal to this right here. And so we have x to the 14th. Well, what do we do when we have a power raised to a power? You just multiply them. So that's x to the 14th times 1/2, which is just equal to x to the 14 halves. And of course, I don't like fractions too much, so 14 divided by 2 is x to the 7th. Let's go into our next one. So for our next one, we have, alrighty, so we do also have another problem, which is going to be the square root of y to the 17th. I brought this one on just a little bit closer so that way we can have a better focus on it. So if we were to rewrite this guy right here, if we were to rewrite it as y, the square root of y times square root of y to the 16th, so these equations, or this expression right here, is equivalent. And if we were to think of this again as y to the 1/2 times y to the 16th to the 1/2 power, and so you can think of it just like that. Almost forgot my parentheses there. And so this will simplify down to y to the 1/2 times, well, 16 and 1/2. Well, that will simplify down to y to the 8th. Well, now we have these mixed radicals here, these mixed exponents, excuse me. And so we have to rewrite that as y to the 8th times the square root of y. And so this is going to be our answer right here, and that's going to be our rewritten expression. We have one other one coming up, which is going to be the square root of 27 y to the 4th. Now, let's go ahead and break up this radical. So by break up, I'm just going to draw an imaginary line right here, and each one gets its own radical. So we have the square root of 27 times square root of y to the 4th. So there's our imaginary line, boop, 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 boop. And that imaginary line is going to represent our multiplication. So there's our multiplication dot right there. So let's break this guy up. So we have 9 times 3. And then, well, this one, we have to use one of our past strategies. So if we have y to the 4th to the 1/2, there we go. So we have our perfect square written right here. And if we go ahead, bring that guy out, we have the square root of 9 times square root of 3. And, well, this simplifies down to multiplied by y squared. Well, this right here, the square root of 9 simplifies down to 3 times square root of 3 times, well, just y squared. And another way to write this is 3y squared square root of 3. Alright. So our next problem that we have going on, this one looks a little intimidating, but never fear. Mr. Robert is here. So, oh my gosh. So let's take a look at this. Again, let's separate this out. So we have the square root of 80 times square root of a to the 5th times square root of b to the 15th. Well, let's make our dotted lines here. Let's try to stay in our columns best we can. If not, I like to think outside the box, or in this case, the line. Anyway, so we have 80 here as a to the 5th and b to the 15th. So let's start off with a number first. So we have 80. Well, let's see if we can divide this up into any of our perfect squares, which is 4, which is going to be 4, 9, 16, 25. 16 looks tempting in this one. Let's just give it a try. So we have 16. Well, let's see if we multiply that by 5. 5 times 5 is 50, times 10 is 30, yep, times 5. That will give us the square root of 16 times square root of 5. Okay, cool. So we simplified this guy down to 4 square root of 5. Okay, getting somewhere, getting somewhere. Same thing with this guy. Let's see if we can separate this into a to the 4th times a. And so, separating this out, we have a square root of a to the 4th times square root of a. Well, square root of a to the 4th, that's just going to be a to the 4th. That's a. Both of them are going to be to the 1/2 power. And so looking at this, these two will multiply together and we get a squared. And then, well, sadly, a to the 1/2, that doesn't do anything, and that just stays as the square root of a. All right, fine. Almost done. Last one. Man, this one's like a 2-in-1, except even better because it's a 3-in-1. So we have b to the 14th times b. And so the idea and the key behind this is that we want to be able to separate our exponent underneath the radical. We want to be able to separate this into something that's even and something that's divisible by 2. Because at the end of the day, what we're trying to do is we're trying to divide this exponent right here. We're trying to divide this exponent right here by 2. And so this isn't divisible by 2. This isn't divisible by 2. Oh, wait, but 4 times 1 is, and 14 times 1 is. So there's a 1 right here, 1 right here. And so whenever we do that, and we have it rewritten just like this, times square root of b, we know that this is just going to be b to the 14th power to the 1/2 power. Well, that's just going to be b to the 7th. And then, unfortunately, our square root of b doesn't do anything. So that's kind of the strategy and kind of what we're going for, the overall theme. So if we have a variable, so x, to a odd power, we want to separate our x to an even power and x to our odd power, which in this case, and most of the times, it should be just 1 right there. And so we have our even power, or so we have x to our even power right here. And then whenever we take the square root of this, so we take the square root of x to our even power, essentially all we have is x to our even power over 2, which in this case is just going to give us another even power, but we still get x to this nice whole number, to this nice, in this case we got 7, and the other case we got 2, so we get this nice number that we can work with easily and doesn't look anything like a fraction or a radical even. Now, so we have 4 square root of 5 times a squared square root of a times b to the 7th square root of b. Now we're done, right? Yeah, like, this looks good. Box it up, call it a day. No. Unfortunately, we can't. So what we have to actually end up doing is putting all of our terms that are under the radical under a single radical. And so the way that's going to look is we have 4. So we have 4a squared b to the 7th. So 4a squared b to the 7th. And then we have one big radical, kind of like a big old house. And we have one big old radical that's going to kind of be our house to hold all of our terms here for 5ab. And then now, okay, now I can box this because that's right. All right. So we got a 3-for-1 there. I was happy about that. And let's see. Let's go to this next free question that we have, or this free space, and let's see if we can solve our next question. So we have -6 square root of 12 a to the 4th b to the 7th. And so kind of using our same ideas that we did in the last problem, let's take a look. So we have -6. That's just going to be way out front, so I'm not going to worry about him too much. And draw these parentheses here, and let's see if we can divide this guy up. So we have another 1, 2, and 3. Okay, so we have another 3-for-1 here. Let's see if we can do it. So square root of 12 times square root of a to the 4th times square root of b to the 7th. And if you're watching this video right now, I do advise you to, see if you can solve this on your own. See if you can figure out what's going on. Don't worry about that. Don't worry about this -6 out front. We'll get to that whenever we get to that. But let's see if you can solve and find the solutions to these guys here in the middle. All right. Hopefully you gave it a try, and if not, well then, yeah. Anyway, so we're going to split this 12 up into 4 times 3, where 4 is one of our perfect squares. Again, that's 4, 9, 16, 25. So we have the square root of 4 times square root of 3. Well, that simplifies down to 2 square root of 3. Ooh, good stuff. I know that's what you got because, yeah, you're really smart. I know you are. And so let's take a look at this next one. So we can actually think of this one, well, this one, we actually have an even number up here. And so because we have an even number, well, all we have to do is just divide that number by 2. So we have a to the 4 divided by 2, and that's just going to be a squared. Man, that's middle term was easy. And let's see, what about this last one? Okay, so now we got an odd number. Darn it. Alright, so we do have to separate it out. So we have b to the 6, which is going to be our even number right here, multiplied by b to the first, which is going to be our odd number. Okay, so we have our even, odd. Well, now all we have to do is just, these guys get their own square root. So it's going to be b 6 over 2. And, well, b to the 1 over 2, that's just equal to the square root of b. Well, this guy right here simplifies down to b to the 3rd square root of b. Alright. So now let's bring everything down here, including our parentheses and our lone survivor out here, our loner out here. We'll bring him in here shortly. We have 2 square root of 3 times a squared times b cubed square root of b. Okay, now we just got to PEMDAS this thing. That is not a P. Now we just got to PEMDAS this thing. So we have PEMDAS parentheses. So let's work out everything within the parentheses here. So all this good stuff. Let's see what we can do. So let's make sure that we put everything and consolidate everything underneath our radical. So we have 2 times a squared times b cubed square root of 3b. And then from there, finally, so our parentheses are done. Finally, we have our multiply or distribute. So we can distribute the 6 and -6, distribute it inside. Well, whenever we distribute this -6, it's just going to our coefficient on the outside. We can't distribute our 6 inside of our radical. No. We're not doing that. So we're only going to distribute it to our coefficient outside of the radical. So we have -6 times 2 is going to be -12 a squared b cubed square root of 3b. And there we go. That's our answer.